Hello, this is Team NCT-M, and I'm presenter Kim Jae-woo. We are living with various machines around us. For example, airplane, car, drone, or even robotic arms. Every machine provides us various types of power to make our lives more convenient. Here, power means 동력. Then, how can they generate power? Almost every machine uses cogwheel gear to generate power. This is the cogwheel gear. This must be familiar to you guys. Mechanism of cogwheel gear is this. The teeth of each gear contact each other. By doing so, they can generate power by interlocking each other. In this mechanism, gear ratio is very important. By adjusting the number of each gear's teeth, we can adjust the speed of this gear set. Let's see this example. Now, this gear set runs in low speed. But if we adjust the number of gear teeth like this, we can adjust the speed to run in high velocity. Like this, if we use different gear ratio, we can get different speed, and it means we can get different power. Each machines need different speed and different power, so they use different gear sets that having different gear ratio like this. But the thing is, they don't need just one pair of gear set. Most of them need one more or two more pairs of gear set. Here's the reason. The vertical axis is force and horizontal axis is velocity of this gear. By this formula, power equals force times velocity. This blue shaded area is the power area. But as we already seen before, each gear set have their own gear ratio, and it means each gear set have their own operating velocity. So the area that one gear set can cover is limited to this area. This is the point. The range of velocity that one gear set can cover is very narrow. But many machines need various velocity. Let's imagine a car. We require all the various speed of the car. Sometimes we need low speed of the car. But sometimes we need high speed of the car. So the car must cover a wide range of velocity like this. To cover more area, car increase the number of gear sets they use. By having various gear sets, they can cover more area. Not only for cars, but also most gear devices need various speed. And it means most gear devices need various gear sets and have various gear sets. Now we know that gear devices have various gear sets. Here we have a question. Then how can they switch to another gear set? The answer is very common sense. Let's think we want to switch to second gear set. Because third gear set is running and contacting each other, we have to break this connection first. After breaking connection, we have to reconnect to the second gear set. One more time. To switch to first gear set, we have to break this connection first. After breaking, we reconnect to the first gear set. The system that performs this series of actions is transmission system, which is the subject of our project. They perform breaking and reconnection actions and help devices to switch to another gear sets. Now, I want to show you how transmission system looks like. This is a transmission system of car. Gearbox lever, clutch, and a set of gears. Now, car is using this gear set. But if a driver wants to run faster, he pulls the lever. When he pulls the lever, transmission system switches to the next gear set. These gear sets have different gear ratio, so the driver can run in different velocity. If he pulls the lever one more time, he can use the last gear set. Based on what we've seen so far, we can find out an important fact. Because cogwheel gears face each other and transmission system has a braking and reconnecting action, transmission system works in a contact way. But actually, these 3 points are the main causes of problems that traditional transmission system has. Our team focused on 2 main problems. The first problem is the size of the transmission system is too big. Because they are contact system, this braking and reconnecting action is inevitable. And to perform this motion, system need bulky parts like clutch or gearbox lever. As a result, system need more parts, more space, and overall size of transmission system becomes too big. Here more problem occurs. Big size devices like airplanes or cars have enough space for transmission system, but medium or small sizes devices don't have enough space for this system, so they cannot use transmission system. All they have to do is just use one gear set and one power area. Second main problem is friction. Because they are contact system, friction is inevitable. This friction makes many unhappy things like efficiency loss, vibrating, noise, or poor durability. So through this project, we try to solve main problems of traditional transmission system. To solve these problems, we thought about 3 points again. The first point and second point are established facts that we cannot touch anymore. So we started from the third point. All of the problems were mainly because they worked in a contact way. So we thought, how about making non-contact transmission system? This is the main subject of project NCT-M, making non-contact transmission system. If we can make it in non-contact way, we can solve all of these problems. We don't need braking and reconnecting motion anymore because they don't contact each other. And also, we don't need bulky parts anymore. There's no more friction too. As a result, all problems due to friction disappear too. For this project, 4 members of 서강 University, 김재우, 윤광일, 홍시영, 임지수, we devoted ourselves for a semester. All the team members worked very hard on this project, and the result was very successful. Now, I will show you our project for each step. Project NCT-M's first step was removing cogwheel gear. To make non-contact system, we thought we have to remove cogwheel gear. If we use the cogwheel gear again, we have to do these motions again, and bulky parts again. So we decided to use a new gear, and we found out a magnetic gear. We will use magnetic gear instead of traditional gear. It works in a non-contact way, and it works by magnet. It has a very compact size and consists of 3 parts: inner rotor, stator and pole piece, and outer rotor. I'll compare this with cogwheel gears for understanding. Inner rotor is small gear of cogwheel gear, and outer rotor is large gear of cogwheel gear. Cogwheel gear turns by power of cog contacting each other, and magnetic gear turns by power of magnet. The number of each gear's teeth determines the cogwheel gear's ratio, and the number of magnets determines the magnet gear's ratio. In cogwheel gear, small gear and large gear are connected by contacting each other. In magnet gear, stator part connects inner rotor and outer rotor. In stator, piece of steel is stud instead of magnet. So the overall gear works by the magnetic force between magnet and steel pieces. By applying magnetic gear to traditional transmission system, we invented new transmission system with this magnetic gear. Second step is designing with magnetic gear. To cover wide range of velocity area, multiple gear sets with different gear ratios are essential. So we need multiple magnetic gear sets. So let's prepare 3 pairs of magnetic gears and connect them in a row. Done. But our goal was making system in a compact size and in an efficient way. For this goal, we redesigned all parts of magnet gear from the bottom. First part is outer rotor. We designed outer rotor more longer like this. These holes are for magnets. Like this, there are 3 different number of holes in 3 areas, so we can provide 3 different velocity. By designing outer rotor like this, 3 different gear ratios can be generated in one outer rotor. Next is stator. Also, we prepared 3 different areas to match with outer rotor set. Here, we attach steel pieces instead of magnet. For inner rotor, we only make one whole area. It means inner rotor is having only one magnet area. With this design, we can achieve the function of transmission system. In outer rotor, there is 3 different magnet area. So by moving inner rotor back and forth like this, we can select 3 different gear ratio. Switching gear and use other gear ratio is the main function of transmission system. Thanks for this design, we don't need braking and reconnecting motion at all. And because there is an air gap, switching action is way more smooth and free from friction. Okay, the third step. How can we move this inner rotor back and forth? You might think this is an easy task, but it isn't. Maybe we can use pulling lever and clutch like traditional transmission system, but the size will be bigger again. Or maybe we can just use our hands and do this linear movement ourselves. But we wanted to invent automatic transmission, not manual transmission. To move the inner rotor most efficiently, we once again designed housing part to attach on the inner rotor. On the outside, we make some teeth like this. And inside, we made thread like this. After designing housing part, we modified our outer rotor. We made thread on the outside of this outer rotor so that it matches with thread of housing. We added a little step motor to rotate this housing part. In the later part, this step motor will be controlled by Arduino. Anyway, by doing this, when housing rotates, the inner rotor can move linearly like this. Now we can move the inner rotor back and forth like this and select 3 different gear ratio. And it means we finally succeeded in developing a transmission system. But we didn't stop here. We actually tried to produce this system in reality and demonstrate it. The 4th step of this project is physical production. Our budget was limited to 500,000 won and our time was limited to 9 weeks. So we used 3D printer to make each part and assemble all the parts by our hands like this. After modeling each part with 3D CAD, we printed out the real parts like this. This is the outer rotor. You can check out the thread of outside. This one is housing. You can also check out teeth of outside. And this is inner rotor. And this is step motor to perform linear movement. Let's see each part more closely. As I've said, we attached magnets and steel pieces for inner, outer rotor, and stator. You can also check out bearing we put it in to prevent vibrating or tilting. With these parts, we checked out that each rotor interact with each other well. And also, we checked out that rotation and linear movement worked very successfully. It works pretty well. With all of other parts, we assembled like this. This is the motor to rotate the inner rotor. When motor rotates the inner rotor, overall system generate power like this. In this part, we face some big problem. As you've seen, we need motor to rotate the inner rotor and the housing need to be moved back and forth. This means the motor should move linearly too. But the problem was motor was too heavy. We couldn't move motor due to its weight. So here we designed one more innovative part. We designed pantograph arm part like this. This pantograph arm is very flexible to its length like this, so we don't have to move motor anymore. All we have to do is just move housing, not motor. Until now, we designed this assembled model in 3D CAD, so we simulate it in virtual area. But in reality, we need real base to support this system. So we printed base part to mount our system like this. And we printed one more base to put the motor on. This is the final assemble of our product. We made this simulation with the 3D CAD Inventor program. And this is the real model we printed out and assembled. Next step, we have to control this system automatically. We used Arduino and we wrote code for control it with one button. Our team member studied day and night and he succeeded to make Arduino control. We will show you later. Okay, now final step. Now that we've finished the production process, I'd like to finish the project presentation with feasibility test of our real model. Here, if we turn the motor on, transmission system will rotate and generate power. Here's the place where the generated power is outputted. If output device is a car, it'll be a wheel. If it's a drone, it'll be a wing. Anyway, for a rigid feasibility test, we bought encoder to check out and display the RPM our system make. And for the Arduino controller and RPM display, we gathered them and produced control box. This is our final product. Great production, right? And this is operating video. As I've explained, you can see the linear movement and you can see the power of the motor is connected accurately and output to the end of the system. Pressing the button, you can see the step motor turning gear and the housing move forward. This is a table of magnet number we used. We put 6 magnets in inner rotor, and we put 18, 28, 36 magnets for the first, second, third gear. By this magnetic gear's gear ratio formula, our theoretical gear ratio is this. Okay, let's go back to our operating video. Here's the first gear area, and here's the second gear area. And move more forward, we can get the third gear area. With this, we checked out the RPM of output with Excel and visualized it. Here, we can clearly see 3 different gear area. This shows that our model have 3 different gear ratio, obviously. These 2 area are the area that between each gear area. This is the error table and comparison table. You can see that error rate is very low. And also, theoretical value and experimental value is almost same. We got a better result than we expected. With these mathematical bases, we can finish our project successfully. Now the conclusion part. You can pause this video and check out how we used our budget for this project. Through this project, we invented whole new transmission system NCT-M. It's a non-contact type system that using magnetic gear. Unlike traditional transmission system, NCT-M has a compact size and 0 friction, so it can be applied to small size devices. This project was a very difficult project over 3 months, but thanks to great team members and professors, we were able to complete the project successfully. Thank you for them, and thank you for listening to this long presentation.